All right, hi folks, this is Larry Maslino. I'm recording a video for MATH022. This is Objective 8. And you're going to see there's a few examples that ask you to write equations in what's called slope-intercept form and then point-slope form, okay? And folks, a reminder, if you go to the reference packet, these different forms of writing an equation of a line are given to you in the reference packet. So you don't have to remember these. Let me show that to you just to point out what I am talking about. So if you notice, here I am in the reference packet. I think I'm on page 6. Let me get that. And if you notice, here is the formula for the slope of a line. Here is the equation of a vertical line, x equals a number. Here's the equation of a horizontal line, y equals a number. And here is what's called the slope-intercept form, y equals mx plus b. M is the slope, b is the y-intercept. Here's another form, it's called the point-slope form, y minus y1 equals m times x minus x1. All right, we'll use these and explain how to apply these in just a few minutes. All right, so let's go back and let's come here. Let's do a few topics. This one says interpreting a line chart. So this is asking you to look at a chart and answer a few questions about it. All right, let's read this. It says the graph shows the number of orders received by a company for 5 months. So it looks like the months are on the horizontal axis, the number of orders are on the vertical axis. All right, first question. What was the least number of orders? Well, I'm looking for the dot that's at the lowest point on this graph. Well, you could see right here in April was the lowest point. Well, what I have to do here is read this number that corresponds to this dot. Well, if this line is 1900 and this line is 2000, in between must be 1950. So the answer here is 1950. All right, now second question. When did the greatest increase occur? All right, so I have to look and see where on this graph was the greatest jump or increase. Well, this part is a decrease, so of course I'm going to ignore that. This part is a decrease. I'm going to ignore that. This part went this, here's the increase from here to here. For this part of the line, the increase went from here to here. Well, I could see this is the greatest increase. So it looks like going from April to May was the greatest increase, so April to May. All right, so for this kind of question, you really just have to read the graph carefully and make sure you understand what the graph is representing so that you can answer the question. All right, let's come here. It says write an equation in slope-intercept form given the slope and a point. All right, now, there's two equations that we were just looking at. There was the slope-intercept form, which is y equals mx plus b. So if you're given a slope, m, and you're given the y-intercept, that's the b value, then you would use this equation, right? You would need to know the slope and the intercept to use that equation. But there's another equation, it's called the point-slope form. The point-slope form looks like y minus y1 equals mx minus x1. You use this equation when you know the slope, so you're given the slope m, but now you're given an xy point. We're going to call it x1, y1. That's when you would use this form in the equation. And notice they gave me the slope of 3, but they also gave me an xy point here. I'm going to call this x1, y1. So because they gave me a point and the slope, I want to use this point-slope form. So let me write it. I'm going to write it as y minus y1 equals mx minus x1. All right, well, I know the slope is 3, so that means m is 3. So I'm going to replace this m with the 3. Our x1 number is a 5. So I'm going to write this as x minus 5 because I'm replacing x1 with 5. Also, I'm going to write here y minus our y1 number. Our y1 number is a 1, so I'm going to write it as y minus 1 equals that. This is the equation, but I'm not done yet because they say write the equation in slope-intercept form. Slope-intercept form is when you have y all by itself on one side of the equation. So what I have to do is a little bit of extra work here to get y by itself. Here's the first thing I'm going to do. I'm going to take this 3 and multiply it inside the parentheses. So I'm going to end up with y minus 1 equals 3x minus 15, right? Because 3 times 5 is 15. Well, I want to get y by itself. So I'm going to add 1 to both sides to cancel out that subtraction of 1. Subtracting 1, adding 1 cancels out. I end up with y equals 3x. Here I can think of this as a negative 15 plus 1 minus 14. So here's the final answer. And I've written it in slope-intercept form. Okay, so folks, there are these two equations, these two forms of an equation, slope-intercept form and the point-slope form. All right, which form should you use? Well, it all depends on what information you're given. If you're given the slope and intercept, then you should use the slope-intercept form. But if you're given a slope and a point, you should use the point-slope form. In our example, we were given a point and a slope. That's why we used the point-slope form for this example. All right, let's take a look here. All right, this one says write an equation of this line. And notice they're giving us the y-intercept and another point. Well, notice by giving us the y-intercept, that kind of suggests to me that maybe we want to use the slope-intercept form. Now, they didn't give us the slope, but we could calculate the slope ourselves by looking at this diagram. All right, so let's do y equals mx plus b. First, I'm noticing the y-intercept here is 1 because the graph crosses the y-axis at 1. So that means our y-intercept, or the b value, is equal to 1. All right, the other thing I need is the slope, m. Well, the slope is the vertical change between the 2 points divided by the horizontal change. So let me count how far I go vertically and then how far I go horizontally, go from one point to the other. Let me go vertically. I'm going to go vertically up this high. Well, if you count, I just went up 6 units. And then I'm going to go over to the right 2 units. So the horizontal change was 6. Excuse me, the vertical change was 6. The horizontal change was 2. Well, 6 divided by 2 is 3. So now we know that m is 3. Well, we have what we need. M is 3, and the y-intercept is 1. So here's the answer. So by looking at this graph, we could figure out the y-intercept. That was 1. And we were also able to figure out the slope, because the slope is the change in the vertical distance divided by the change in the horizontal distance between the 2 points. All right, let's take a look at a few more. What if we take a look at this one? It says find an equation of a line that passes through these 2 points. All right, well, it never hurts to graph or get a quick idea what the line looks like. Let's do that. So 1, negative 1 would be here, and negative 5, 1 would be up here somewhere. So this line looks like it's going downhill. So I can see it's going to be a negative slope. Well, I'm noticing they're giving me a point, and I could find the slope myself. Well, if I have a point and the slope, that suggests to me I should use the point-slope form of the line. Well, for that, the format is y minus y1 equals mx minus x1. All right, well, let's find the slope. We need the slope m. Well, the formula for that, this is in the reference packet, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to label these points to make it easier to work with. This is going to be x sub 1. This is going to be y sub 1. This is going to be x sub 2, and that's going to be y sub 2. All right, let's plug into the slope formula. Our y sub 2 number is 1. Subtract the y sub 1 number, which is negative 1. Got to be careful when I subtract the negative. The x sub 2 is a negative 5. Subtract the x sub 1 number, which is a 1. All right, but when you subtract the negative, it flips to the addition. So it's going to be 1 plus 1. 1 plus 1 is 2. And on the bottom, it's negative 6. Well, I can simplify this to be negative 1/3. All right, that's the slope. Now I'm going to plug in here y minus y1. Our y1 number is a negative 1. Our slope m is negative 1/3. X minus x1 is a 1. The only thing I'm going to do here is, because I'm subtracting the negative, it flips to the addition. So I'm going to write as y plus 1 equals negative 1/3 x minus 1. And I can leave my answer like this. Alex should take the answer in that format. All right, so when they give you 2 points, you can calculate the slope yourself. That means you're going to know a point and a slope. Well, that's the time to use the point slope form of a line. All right. How about we take a look at this one? All right, it says write equations for horizontal and vertical lines passing through the point -7, -2. Well, I know a horizontal line is y equals some number. In the reference packet, they show it as k. K is just representing any number. A vertical line I know is x equals some number. You know what? I'm just going to put a box here because we don't know what these numbers are. That's better. I'll just put like an empty box. We have to figure out the y values and x values. Well, remember, this is the x and y coordinate they're giving us. So what you do is you just plug in the y value here. The y value is -2. This is a horizontal line passing through that point. And for the x value, I'm going to plug in x equal -7 because that's the x coordinate they gave us. This is the vertical line passing through the point. So if I was to write or graph this, -7, -2 would be down here. Here's the horizontal line passing through that point. And here's the vertical line passing through that point. The equation of this horizontal line is y equals -2. The equation of this vertical line is x equal -7. All right, let's see. What if we come here, identify solutions? All right, well, this problem, this topic introduces what's called a system of equations. A system of equations is just more than one equation to be solved at the same time. So what they're giving me is 2 equations here. I'm going to call this equation A and equation B. And they're going to ask me, is 5, 0 a solution? Well, for 5, 0 to be a solution to the system of equations, it means 5, 0 must be a solution for both equation A and equation B. It's not good enough that it's just a solution for equation A. It's got to be a solution for both. So let's try it out. Let's take equation A. 6x minus 7y equals 4. I'm going to check 5, 0. Well, I know 5 is the x value and 0 is the y value. So I'm going to plug in x equals 5 here. And I'm going to plug in y equals 0 here. And I want to know if this is a true equation or not. Well, this is going to be 30 minus 0 equals 4. That's 30 equals 4. That's a false equation. I'm not going to bother checking in equation B because once it fails to be a solution in equation A, automatically it's a no. Because for me to check the yes box, the XY point they give me has to be a solution to both equation A and equation B. All right. So let's do one more here. How about if we try 3,2? So let's see 3,2. Let's try this one. Is 3,2 a solution to the system? Well, we've got to check it in both equations. So remember, this is the X value and this is the Y value. So let's check equation A, which is 6x minus 7y equals 4. All right, the X value is 3. The Y value is 2. Let me see if there's a true equation. 6 times 3 is 18. 7 times 2 is 14. 18 subtract 14 is 4. So this is a true equation. That's good, but it's not good enough. We've got to also check equation B as well. So equation B is negative 5x plus 3y equals 8. Let's check it here. For x, I'm going to replace it with the number 3 because that's what the x value they gave us was. And for y, I'm going to replace it with the number 2. Let's see if this is true. Negative 5 times 3 is negative 15. 3 times 2 is 6. Negative 15 plus 6 is negative 9. And negative 9 does not equal 8. So this is a false equation. So this is not a solution, right? Because this XY point would have to be a valid solution for both equations in order to be valid, which it's not. So the answer here is a no. So the answer here is also no. All right, so again, you have to get a XY point that's a valid solution to both equations in order for you to be able to say yes. All right. What if we take a look at another example here? All right. Now, they're giving us a graph of each of these two equations. So let me try to explain what they're showing us here. They're showing us line 1, and they've graphed it. Notice here it says L1. So this graph is line 1. Line 2 is this equation. They've graphed it for us. Here it is L2, they call it. So this is line 2. Well, I'm noticing these are parallel lines. What they're asking me to do is classify the system of equations. Well, here's where the reference packet is going to be your best friend. Let me go to the reference packet and show you that there is a diagram here. Let me try to get this side by side if I can. There is a diagram here that tells you, I'm going to make this a little bigger maybe. Here is a diagram that tells you how to classify these graphs. All right. So it says here, notice we have parallel lines. Well, if you have parallel lines, notice it says the system is inconsistent. So I'm going to come here and say inconsistent. Okay. All right. Let me come over to the second graph. Well, the second graph, when they graph line 1, here it is, and they graph line 2, here it is. What they're trying to tell you is these two graphs are sitting on top of each other. So these two graphs are overlapping. These two lines overlap. It's hard to see because the two graphs are sitting right on top of each other, but the two graphs are overlapping or coinciding. So we could say overlap, we could say coinciding. Well, here's the graph that corresponds to it, coinciding lines. All right. It says the system is consistent and dependent. Consistent and dependent. Here it is. All right, let's do one more. What about, here's line 1. So here's line 1, and here's line 2. And notice these two graphs just intersect. And if there's one point of intersection, it says here the system is consistent and independent. So consistent and independent, that's going to be this answer choice right there. All right, so folks, so use this guideline here in the chapter summary to help out with these kinds of Alex questions. Remember, a lot of the formulas, like the point slope form, the slope intercept form, all of those are in this reference packet. All right, folks, hope this is helpful as you are working here in Objective 8.